Good morning, everyone. My name is Mahfoudh Senhoury. I'm a CS major at Lehman College. I'm part of the NSF REU program at FAU. And today I'm going to be talking about how I built a digital twin based evaluation of urban traffic systems. We're going to go through the motivation, the background, why it's important, the research objectives, and the experiments I've used to kind of like compare the, my other scenarios which I have developed, and the methodologies, results, and conclusion. So before I start, I just want to talk about why this is important. So I'm solving a really important problem. On the far left, you have Federal Highway Administration investing billions of dollars every year, and through federal highway programs and infrastructure investment and job acts. And on the right, you have reports from INIX, which are like it's a private company that reports data from cameras and traffic every year. And you see like cities like Chicago, New York, um, have spending massive amount of money, billions of dollars every year, which is a big deal. So basically, what I'm really saying, America spends a lot of money every year on traffic. So the average person would spend like 60 hour on average on traffic, translating to billions of dollars every year, um, which is which is a big deal. So, but the real kicker is that billions of dollars are, are being, you know, are being invested in infrastructure, but infrastructure decisions that are being still in historical old data that don't really reflect the actual, condition of the roads. So that's when my question comes in. Why should we not predict, you know, using it by using a digital twin? So my question here is saying, how can we predict the impact of future infrastructure changes on traffic before implementing them into the real world? So the reason why America spends a lot of money because probably they don't really predict the traffic, the intersections, and that's one of the reasons. So so I went ahead and did built a digital twin to kind of experiment on what's going to happen if we um, if we just have if we just use real data and just have our own predictions. So this is my model. This is what I've used to build my digital twin. It's in Boca Raton here, westbound Glaze Road, and I focus on these two roads and southbound Airport Road. So methodology. So these are my technology stacks I've used. So basically, these are just the icons of the applications. You have Sumo, which you like run the model on, and then you have NetEdit, which you just edit the network, and then XML files, which are from Sumo, and then Python, which you read data from XML files. So it's the pipeline is looking like this. Sumo, throws data, and then Python reads them, and then you take data from FDOT, and then you kind of like compare if it's like matches or not, and then you get your target. So experiments pipeline. So basically, you choose a road, right? And then once you do that, you try to find the data from the government or from some cameras. And then once you do that, you have your digital twin. Once you have your digital twin, you can like run experiments, changing things in the road or in the intersection. And then once you do that, you have your analysis performance. So basically, we took those three steps and we're gonna like, break them down even more to four steps. So we have first the net edit, which is where you kind of like edit your network, and then you have Sumo, which you simulate the network with vehicles. But it's only like a video game now until you use real data from FDOT, which is our metrics, which is why we just how we use which is how we make things real. So to make it real, to make it not like, to make it look like it's high fidelity at the very least, we use FDOT. And then that at the very far is VS Code. That's the data that we have from the simulation runs. So this is my network at first. You see vehicles, those yellow things you see are just cars and trucks. And then all I did was I just added a connector. So to kind of experience on what's gonna happen and run analysis on and like compare them to and see what's gonna happen. So before I even like make things, tell myself this is a high fidelity, accurate network, I'm using FDOT. And FDOT has like, you click on the road, it gives you all the metrics, things like ADDT, annual average daily traffic, which is like the average time a person spends on traffic in a year. And then you have the peak hour, which is what you see here. So in total, it's around 4,500 vehicle per hour. So that's like what we got from FDOT. And that's the application running. And on the far left, you have VS Code. So I'm just showing you guys like what it looks like, how the application is running and everything. Those are vehicles and it's ending here. Then like it dumps data into VS Code, raw operational data that we use later on to use like things. So things like how many vehicles have entered, how many vehicles have left the edges, and then we add that all, and then we have our volume that we compare that to against FDOT. So basically, we're using a GAH statistical formula to just kind of validate to see if our data is calibrated, see if it's real or not. So well, I found out that it's kind of close to within 5%, which is passable. So that's a great news. So all I did is I just added a connector from Blaze Road to airport southbound. So I found out that there's 382 vehicles that went from westbound to they were in westbound and they went up to southbound. So that kind of decreased the number of vehicles from westbound. So less traffic, and that's a great thing for traffic in the intersection, so that there's no So conclusion. So basically, in order for us to have a high fidelity digital twin, we're gonna have to have at least some real, concrete data that reflects on real conditions that's happening outside. And adding an alternative would have a huge impact if you really use real data. And that's we saw 16% decrease in traffic in westbound, which is a big deal. And then the methodology we're using here is kind of like you can use it anywhere. So where you are, you can just go anywhere, use the same application I use, because all I did was I imported my network from OSM Wizard, converted that to NetEdit, and then there you go. So all you need to do is follow the same methodologies. So I thought about having some kind of future work. Basically, what I'm saying is, what if we have, instead of like having static, data from like report from yearly, what if we have like dynamical data that is live? So basically, I developed a pipeline that takes the dash footage, and it gives it to Yo to kind of like track the number of vehicles like in the intersection, and then gives it to Bytrack to assign IDs to count number of vehicles. This is important to have also both like static and dynamic data, so that we can have a high fidelity digital twin that actually reflects the network. So also, this could be used in places that don't really have cameras, because what if the data that we use from last year is different than this year? So that's also very important. And so this is a footage I took. I also went outside and took a video and gave it to YOLO and tracked the vehicles. I was just a curious researcher, so you kind of want to try out. And I want to thank NSF and CS3 for sponsoring this research, and iSense, of course, Lehman College. I've learned a lot about like digital twins and everything. So yeah, thank you.